dimensions and dimensional analysis. Okay, first of all, what is dimensions, that we'll see. You know that there are 7 fundamental physical quantities. These are what? Length, mass, time, then temperature. We give symbol to temperature as K. Then there is current. We give symbol to current as I. Then luminous intensity, we give symbol C. And then there is amount of substance, and we give its symbol as MOL. So these are the 7 fundamental physical quantities and their respective symbols which we use in dimensions. Now first of all, what are the dimensions? Dimensions is nothing but powers of the corresponding fundamental physical quantity we have to raise to show the original physical quantity. I'll explain you with the example. Let's take example of velocity. Okay, what is velocity? Velocity is equal to displacement upon time. What are the units of velocity? Meter per second. So simply we can write it as meter second raised to minus 1. This is space or hyphen. Okay, and from that we can write dimensions or dimensional formula of velocity as L m t, and this is what? Meter. So meter is related to length, and there is nothing but 1. So L raised to 1, because here is 1, and S raised to minus 1. S means what? Time, and time raised to minus 1 we will write. And as there is no mass quantity present, so M raised to 0. So these are what? These are the dimensions of velocity or dimensional formula of velocity. So in this way we can show the dimensions. One more example I will show you. What is charge? Charge is equal to current into time. Unit of charge will be ampere second. So what will be the dimensions? L, M, T and I. These 4 quantities will present. Let me tell you why only we are going to take I. As we can see, despite L, M and T, only current quantity present in the formula. That is why we are going to take I. Here are the symbols of those quantities which we can take. So what will be the dimensions? As length is not present in the formula of charge, so 0. Mass is also not present, then therefore power of mass is also 0. Time present, so time raised to 1, and current also present, that current raised to 1. So this is what the dimensional formula of charge, or simply we'll call it as dimensions of charge. One more example let me give you. Let's take example of force. Okay, what is force? Force is equal to mass into acceleration. Now what is acceleration? Mass into acceleration is velocity upon time. Now what is velocity? Velocity is displacement upon time, so time square will come over here, and simply its unit will become kg meter second raised to minus 2. Kg meter second raised to minus 2. So what will be the dimensions of force? Dimensions of force will become L raised to 1, M raised to 1 and T raised to minus 2. In this way we can find out dimensions of any physical quantity. I hope guys this is clear to you. Now let's go ahead. Let me take you to next topic, that is uses of dimensional analysis. First use of dimensional analysis is to check Okay guys, so first use of dimensional analysis is to check correctness of physical equation. For an instance, let's take one physical equation. S is equal to ut plus half at square. This is the third law of motion, and we have taken it as an example to check correctness of this equation by using dimensional analysis. Here you can see there are 3 terms. Okay, and here you can see which is a constant. We don't have to consider this constant while doing dimensional analysis. Okay, now when we will say this physical equation is correct, when dimensions of all the terms, it means this term, this second term and this third term, all the dimensions of these three terms will come same, then we will say this physical equation is mathematically correct. So let's check dimensions of S. Dimensions of S. Unit of S is meter. So what will be its dimensions? What will be the dimensions of S? It is L1 only. We can write by this way also, or we can write like this also, m raised to 0 and t raised to 0. If there is no need of mass and time, then we can simply skip it, or we can take it, there is no problem. Dimensions of S is L raised to 1, m raised to 0 and t raised to 0. Now let's consider second term, which is ut. Dimensions of ut we will see. Ut, what will be unit of it? Its unit will be meter per second, as u is the initial velocity, meter per second is the unit of it, and into second again, because time is second. So S will get cancelled, so ultimately unit of ut will become m, and its dimensions will be same, L raised to 1, m raised to 0, t raised to 0. Okay, let's go for our third physical quantity, that is at square. Okay, as I already told you, this 1/2 is the constant which is dimensionless, and we don't have to consider it while doing dimensional analysis. Okay, so what will be unit of it? Unit of acceleration is meter per second square, and this time square is nothing but second square. So second square get cancelled, and ultimately its unit will become m, and its dimensions eventually L raised to 1, m raised to 0 and t raised to 0. So you can see this is suppose equation number 1, this is equation number 2, and this is equation number 3. From equations 1, 2 and 3 you can conclude, as dimensions of all the terms present in given equation are same, that is why you can say this equation is mathematically correct. So that is what about first use of dimensional analysis. Let's go for second use of dimensional analysis. Second use of dimensional analysis is to establish relationship between related physical quantity. For an example, we take simple pendulum. What is simple pendulum? Simple pendulum is the string or rod, and here is weight attached to it, and here is the support. This is length of the string or that rod, and here it is the bob or any object which is tied at the end of this string or rod. Okay, and what happens? It oscillates in particular limit. This is suppose its extreme left, and this is suppose its extreme right position, and what exactly the time period of it, that we are going to say. Okay, you know what is time period. Time period of simple pendulum is nothing but time required to go to this bob to extreme right, then again to its original position, then again to extreme left, and then again to its original position. So this is nothing but the one complete oscillation, and time required to it is nothing but the time period. So this time period is dependent on which things? Dependent on length of the pendulum and g. So let's take t is proportional to L raised to a. Why it is proportional to length of the pendulum? Because length of the pendulum, if we increase length of the pendulum, time period will also increase. That is why time period is proportional to length. And let's take power of the L is a, that we need to find. Similarly, t is proportional to g, and let's take power of it is b, which we have to find out. Let's put them together. T is proportional to L raised to a and g raised to b. To eliminate this proportionality sign, let's take one constant k L raised to A, G raised to B. So now what we have to do by using dimensional analysis to find out value of A and B. Okay, now we can do one thing. We know that we have already seen in first use of dimensional analysis that equation is mathematically correct only if dimensions of all the terms are constant. So here dimensions of t and dimensions of term present in right hand side will be same. So it means what are the dimensions of left hand side? L raised to 0, m raised to 0, t raised to 1 should be equal to dimensions of this L. What is the L? L is length, L raised to 1, m raised to 0, t raised to 0. And what are the dimensions of G? G is nothing but the gravitational acceleration. Let me tell you what will be dimensions of G. G is nothing but acceleration. Acceleration is nothing but velocity upon time. Velocity is nothing but meter per second and this second present. So meter per second square is the unit of G. So 1, 0 and t raised to minus 2. These are the dimensions of G. So we will put powers of those. Power of this will be A and power of this will be B. And keep in mind this K we don't have to take into consideration as it is dimensionless constant. So L raised to 0, m raised to 0, t raised to 1, this left hand side will remain as it is and right hand side will become L raised to this 1 into A, m raised to 0 into A, 0, t raised to 0 into A is 0. Again L raised to 1 into B is L raised to B, m raised to 0 and t raised to minus 2B. So eventually it will become L raised to A plus B, m raised to 0 plus 0 and t raised to 0 minus 2B. As bases are same, we have added the powers of it as these are in multiplication with each other. So left hand side, let me write L raised to 0, m raised to 0, t raised to 1. So simply you can see there is left hand side and there is right hand side. In left hand side also bases are same, powers of these bases should be same. So we can simply write two equations. One equation will be A plus B is equal to 0. What did I do? I equated powers of length on left hand side and right hand side. This is suppose equation number 1 and I will also get equation number 2 by equating powers of t, that is minus 2b is equal to 1. From this equation we can get value of b. B is equal to minus half. So this is the value of b. From equation number 1 we can get value of a minus 1 half is equal to 0, therefore a is equal to plus half. So it means what? We got value of a and b and let's put those in the equation. What is the equation? T is equal to k into L raised to a and g raised to b. T is equal to k into L raised to half into g raised to minus half. So it will become k into the square root L, and as it is minus power we will send it to denominator and it will become under root g, which is at denominator, and simply we can write k in under root L upon g. But here one thing is remaining, that is value of this k. This value of k we can't find by using dimensional analysis. That is what the limitation of dimensional analysis. But this value can be found out experimentally and that value is 2 pi. So therefore our ultimate equation becomes t is equal to 2 pi into the under root L upon g. So that is what the final relation between time period of the simple pendulum with length of simple pendulum and gravitational acceleration we found out by using dimensional analysis. That is what the second use of dimensional analysis. Let me take you to third use of dimensional analysis, guys, to find conversion factor between units of same physical quantity in different systems of unit. So now what are the two different systems of units? SI system and CGS system will take for example, and we'll take one physical quantity, that is force. What is the SI unit of force? SI unit of force is Newton and CGS unit of force is dyne. Let us find conversion factor between Newton and dyne. Let's say 1 Newton equal to X dyne. So what exactly we have to do? We have to find out value of this X, and then we'll say that there is a relation between Newton and dyne is 1 Newton is equal to that much dyne. Okay, so on left hand side I am going to write dimensions of force L, M, T, but SI unit I will write L1, M1 and T1, and L raised to 1, M raised to 1, T raised to minus 2, X into L2 raised to 1, M2 raised to 1 and T2 raised to minus 2. Okay, we already have seen dimensions of force are L raised to 1, M raised to 1 and T raised to minus 1. I am just keeping this suffixes 1 for left hand side and 2 for right hand side for CGS unit. Okay, so what will be the X? X will be L1 raised to 1, M1 raised to 1 and T1 raised to minus 2. X is equal to L1 raised to 1, M1 raised to 1, T1 raised to minus 2 divided by L2 raised to 1, M2 raised to 1 and T2 raised to minus 2. Okay guys, so X is equal to, I will write separately L1 upon L2, as powers of L1 and L2 are 1, so there is no need to take 1. Similarly M1 upon M2 and T1 raised to minus 2 upon T2 raised to minus 2 we will write. X is equal to length. What is SI unit of length? Which is meter, and CGS unit of length is centimeter. What is SI unit of mass? SI unit of mass is kg divided by CGS unit of mass, that is gram, and here SI and CGS unit of time are same, that is second raised to minus 2, second raised to minus 2. Okay, so what will be X? X will be, what is meter? Meter is nothing but 10 raised to 2 centimeter divided by centimeter as it is. What is kg? Kg is 10 raised to 3 gram divided by gram as it is, and here this will get cancelled, so 1. So X is equal to what? 10 raised to 2 into 10 raised to 3, because this centimeter will get cancelled, gram will get cancelled. So X is equal to 10 raised to 5. So therefore our assumption was 1 Newton is equal to X dyne, and therefore 1 Newton is equal to 10 raised to 5 dyne. So in this way we have found out conversion factor between two units of same physical quantity by using dimensional analysis. So that is what all about uses of dimensional analysis. Let me take you to new topic, that is limitations of dimensional analysis. Okay, so there are few limitations of dimensional analysis, like we have seen first limitation, that in the formula we obtained T is equal to K into square root L upon G. This K was 2 pi. Okay, K was 2 pi, which we could found experimentally, but we can't use dimensional analysis to find this K. So what is the first limitation of dimensional analysis? First limitation of dimensional analysis is we cannot found out value of dimensionless constants. Second limitation of dimensional analysis is we cannot use dimensional analysis for establishing relations between two physical quantities if the functions like trigonometric functions, logarithmic functions and exponential functions present in the equations. It means what? If suppose there is the relation x is equal to y log z, then we cannot use dimensional analysis to set this relation. Similarly, if trigonometric functions like sine, cos, tan, etc. presents in the equation, we can't set the relation between two physical quantities with each other. Similarly, if exponents present like e raised to x, then also we cannot use dimensional analysis to set the relations between two physical quantities. So that is what the second limitation of dimensional analysis. Let's go for third limitation of dimensional analysis. Okay, to see what is third limitation of dimensional analysis, let's consider one formula. Force of attraction between any two bodies is equal to G m1 m2 upon d square. m1 and m2 are the masses of these two bodies and d is the distance between these two bodies. This F is the force of attraction between these two bodies. But you can see one thing present over here, which is G. What is G? G is actually constant, which we call it as universal gravitational constant, and which is not dimensionless. G is 6.67 into 10 raised to minus 11 meter cube per kg second raised to 2. It means what? It is not dimensionless. If such a constants present in the mathematical equation which is not dimensionless, at that time we can't use dimensional analysis to find out a relation between physical quantities, as well as we cannot use to check its mathematical correctness. That is what the third limitation of dimensional analysis. Let me tell you fourth limitation of dimensional analysis. For knowing fourth limitation of dimensional analysis, let's take one example. V is equal to u plus at. This is the first law of motion. For an example we have taken over here. V is the final velocity, u is the initial velocity, a is the acceleration, and this t is the time. So v is equal to u plus at is the equation. But if we take v and at only, then we can set this equation by using dimensional analysis. But by using dimensional analysis, we cannot guess that there is one more physical quantity present, that is u. So this is also the limitation of dimensional analysis. I hope you found it useful. Still, if you have any doubts, you can ask me in comment section below. I will try to answer those. And if you found this lecture series useful, please don't forget to subscribe our channel. I will see you in the next lecture.